the ಶ್ರೀನಿವಾಸ್ ಇದ್ದಾರಾ? ಓಕೆ. ಎಲ್ಲರೂ
Hello. Okay, hi guys. My name is Mahira. We start with our session. So, as you guys may already aware of, the session is for 5 days. Today we are just going to discuss about the basic introduction of your IoT and how this IoT is going to work and how it's actually going to apply in future in industry side. These are the concepts today we are going to discuss. So in upcoming days, probably you guys will get a better idea about how this IoT we can implement and how this IoT is going to change and rule the world. So this kind of ideas you guys will definitely get by today's session. And upcoming sessions, I can assure that you guys will get the idea about how to develop a IoT product. So these are the things that we are actually going to get it out. So, okay, so artificial intelligence, that's actually your question is well and good. Okay, I will explain how to learn artificial intelligence and how artificial intelligence is actually implemented in this things. I will definitely explain with you guys. See, the very first thing here is let's we first just kickstart our session with what is IoT and how this IoT is going to applicable with our industries. So then I will explain your doubts. 1 minute, I will share a screen. So any idea about IoT, guys? What is IoT? So IoT, that is nothing but Internet of Things. Okay. So this Internet of Things, yes, exactly, it's an Internet of Things. So what is Internet of Things? So Internet of Things is nothing but connecting device. Simply telling, this Internet of Things is mainly used to connect the devices. So different kind of devices. How we are going to connect with each other. So that's what IoT is. Exactly. So it is actually going to connect your physical things with the internet, not only with internet, with any connecting protocols. It may be a Zigbee, it may be a Wi-Fi, it may be your Bluetooth, it may be a RFID, it may be any connecting device. By using some connecting device, we are just going to connect your physical things each and with each other. So that's what your Internet of Things is. So when you are starting with this Internet of Things, we need to very much aware of your network applicants. Like first, we need to be aware of networking as well. The reason is when we are making an IoT, it is a complete network. So for that perspective, we need to be aware of network as well. Then your IoT, when we are just going ahead with your IoT, so your IoT needs sensors. Sensors is the very important thing in IoT and control devices. So this all the things together, we can able to create some communication, and we can able to make an exchanging the data by using those communication. So your IoT is nothing but connecting the embedded devices by using some internet infrastructure. That's what your IoT is. So when we are just going ahead with your internet of things, your mobile, it can be able to connect with your fridge, it can be able to connect with your kitchen accessories, your kitchen accessories, it can be able to connect with your TV. So connecting different devices with each others, so that's what your internet of things. Okay, so the reason we are going for internet of things is efficiency. So efficiency, it will give you the better efficiency, and it will increase your economic value, and it will give you the most quality of life. So when you are going for internet of things, definitely you will get a more secure life. So this all some advantages, but the disadvantages, we'll be going to lose the privacy. So the privacy part is a disadvantage. When you are choosing any field, it may be any kind of field, that field will have advantage and disadvantage. So the same in IoT, we do have advantages and we do have a disadvantages as well. When it comes to advantage, it is more efficient. You can able to achieve most of the things in a shorter time, and it will give a most economic value. It will help us to increase the economic value, and it will improve the quality of life. It will make communication better. Comparatively now, it will make your communication more better. It will make humans life very easier. So this kind of things will be advantage for internet of things. Disadvantages, we will be going to lose the privacy. So how to overcome these disadvantages and how to focus more on advantage, this all the things now I'm just going to explain with you guys in an interview perspective. So when you are just going ahead with the internet of things, how potential is this in market? So if you are stepping out right now, IoT, you will get 25% of job openings for IoT. But the next year, you will get another 30%. The next to next year, it will be keep on increasing your potential in market. So in 1940, when plastics comes to market, everyone told it is very difficult to be successful for plastic products. But nowadays, without plastic, we are not using anything, right? So the same kind of things, as we are launching slowly the IoT products, when we are slowly launching the IoT products, people used to tell IoT completely launching is a very difficult. Not like that. Just now we started like plastics. We can able to achieve the complete IoT, which will be going to implement our day to day life. So your internet of things, it's actually covering all the areas like our normal consumers, even our household items, and in IT sector, and obviously in industry, agriculture industry, and power plants, and chemical plants. So everywhere we can able to implement your IoT. So when you are going to implement IoT, we need to focus on lot of things. So if you are planning to implement IoT in home, that is a different thing. If you are going to implement IoT in industry, that is going to be different thing. So I will explain how home IoT will make a difference from your industry IoT. Those are the things I will explain. So before we are covering the difference, let's we start with the architecture. So you guys will get the exact idea about how IoT is exactly looks like. So as electronics peoples, the very important thing is not only for electronics, even if you are going for an industry as a developer, or if you are going for an infrastructure, or if you are going for an automation, if you are going for any field, architect is very important. Without this architect, we will never start to develop the projects. So first thing is we will start with implementing the IoT products. So your architect of IoT, we differentiate in 4 stages. Stage 1 is wireless, it may be a sensor or actuators. Stage 2 is your data conversion. Stage 3 is your pre-processing. Stage 4 is data center or cloud. Okay. So when you are going ahead with these four stages, each and every stage needs its own expertise. Okay, that's I will explain now. So when you are going for a stage one, so this is a stage one in the Internet of Things, the things, okay, in IoT, Internet of the things that is nothing but the stage one, okay. So usually when you are planning to implement a small circuit, we need one input, we need one controller, and then we need one output. That input, that is nothing but your sensor or switches or actuators, it may be any kind of thing. So that's input, that may be a wired or that may be a wireless, that depends. It may be a wired or it may be a wireless, that depends. So in the Internet of the things is that main part will be going to cover in the stage one. So it may be you are going to give one input. Once I get an input, we need the gateway to send the signal. So that may be a data acquisition system or internet gateways like your router or switches, anything. So you can able to send your sensor data to cloud or somewhere else. You are just going to process the things. So for that perspective, we need our stage two. So in stage three, mostly it is your network connection. So you can just identify the stage one and the stage two as a one edge, and stage three, stage four is another edge. So by using the internet gateways, you are just going to send your data for the pre-processing step. Pre-processing step means once I receive the data, I will first make my machines to understand the data. So that is the concept we used to tell as a pre-processing or analytics. So this analytics will happen with the help of Wi-Fi, cellular, or your RFID something. So this Wi-Fi or your cellular network or RFID or Zigbee or Bluetooth, something will transfer my data to this Edge ID. So in this Edge ID, I will be going to pre-process my data. Once I pre-process the data, definitely we need to store the data. So for those kind of storing purpose, we need a data center or cloud. Very previous, very older side. So probably 2012 or 2008, this 8 to 12 in this timing. When we are going ahead with this stage 4, we don't have a data center or a cloud. We do have only databases. Now the databases are upgraded to this data center or cloud. So in this four stages, the very first stage, we need someone who's going to design the best circuit. So it's a very important for the circuit designers. So that is 100% core electronics. So after it's done, we need some programs which is going to implement in the circuit, and it's going to process my input data to my analytical or this edge IT. So in this second internet gateways, we need to apply some programming language to my circuit. So what it will do is it will process and it will send the data to the edge IT. So edge IT will pre-process the data. So what kind of data is received? Either it's received 0 or 1. That's nothing but true or false. So based on what it's received, it will pre-process the data. So once it's pre-processed the data, what we are just going to do here is we are just again going to this cloud, and it's going to save the data in our cloud. So this complete process is your IoT architect. So when you are going ahead with your IoT architect, so the stage one, it may be anything. It may be a sensor, or it may be your watch, it may be the machine, it may be the people, it may be animals, it may be anything. But whatever you are receiving, it's going to process with the circuit. So this is what your complete IoT architect is. So any doubts in this IoT architect, guys? So in this theory, you having any doubts? So you can ping your doubts. So the next thing is, so whatever we just discuss, super. So what are we actually doing in these stages? Okay, that I will explain in depth, the most clear. I will put one video. After I explain this video, I will answer your questions. What are we actually doing in the stages? Then what's exactly IoT is? These two questions I will tell you this. See, simply telling what exactly IoT is: connecting devices. The very simple thing, simple example for your IoT is, hope you guys may have the Bluetooth watch. So your watch is connecting with your mobile. So your mobile and watch is getting communicate with each other. So if someone is sending an message, you are receiving in your watch. The same kind of, what if my fridge will send some notification to my watch? So that's what exactly the IoT is. Simply telling IoT, that is nothing but connecting devices with each other. That's what IoT is. Okay. So hope Mohammed, you may cleared about what exactly IoT is. IoT, that is nothing but connecting devices. That's what IoT is. Okay. So stages. What are actually doing each and every stages? Let me share you one small video with you guys. So that video will help you guys to understand how IoT is help us to, how this each and every stage is applicable in real time, that you guys can understand. 1 minute, I will share the video. So kindly observe this video. Hope you can able to see the video, right? So you guys have a look on this video, right? So now you guys just recall the video. Now I will compare the video movements along with this four stages. So you guys will get some idea about the four stages. Okay. Okay, so slowly I will first I will go with this. What are we actually doing in the stages, and your doubts in stages. Doubts first I will clear. See, the very first thing is when some person is entering into the room. So the room light is automatically it's getting switched on. So for that perspective, once I am entering, we have a motion sensor, motion detector sensor, right? So those kind of sensor will help us to identify some motions. Okay. So if one motion is comes in, so if I am coming inside or I am going outside, so that must be I need to process. So in the stage one, I am using my motion detector sensor that is known as our PIR sensor. So I am placing a PIR sensor in my door. Okay, so if some person is coming near, so I will detect my motion. So what my motion will do is it will just process something. So my sensor is going to detect the movement. So that's what your stage one is. So in the stage two, what it will do is this is a data acquisition systems. What it will do is it's going to connect your sensor network for with your output. So simply telling this is your digital analog to digital or digital to analog, whatever itself, this kind of conversion. So as you guys are, hope everyone is from electronics background, so you guys may aware of how the sensors works. See, analog input and digital output is our sensor process. Your analog input is your sensor and your digital output is your sensor output. So this processing analog to digital, digital to analog. So conversion of analog to digital, digital to analog, we are just going to deal with this second part. So the same, why we need to convert analog to digital is, see, sensors needs analog signals. This Wi-Fi, router, LAN, your Bluetooth, Zigbee, it's all needed digital data. So getting analog input and giving a digital output, that's what your second stage is exactly doing. So after I converted my analog to digital and I can able to give the details to my connecting devices. So the connecting devices, that may be anything. It may be internet or it may be a sensor or it may be a Zigbee or it may be a Bluetooth, whatever itself. So that's what your second stage is, how it's actually working. So in the third stage, what is exactly going to do is the output which I am given. So the data needs to process furtherly. So in stage 3, we usually implement the data analytical, artificial intelligence concepts, those kind of things. So in that video, your fridge is telling the eggs and rice are out of stock. How fridge can know this is rice and this is egg? So fridge is one electronics device. So what it's going to do is it's having some sensors and it's having some cooling system. So what it's actually doing is that machine is ready to only cool. But how that machine knows egg is out of stock? So for that perspective, we need artificial intelligence to be programmed in your IoT device. So for example, this concept is known as an image processing. So what we will do is your fridge can able to identify the images in each and every rack. So your fridge can able to identify this is egg. So how it will identify is based on artificial intelligence. So in artificial intelligence, we have the concept of image processing. So when I am giving the horse image to my camera, my system will detect, okay, this is horse. Sometimes it will detect that horse as a dog. So this are some drawbacks in artificial intelligence. That's a different concept. But we are actually working to come ahead with all these disadvantages. Okay. So that's a different thing. this kind of image processing, this kind of artificial intelligence also needs to be implemented in your IoT. So those kind of implementation, and when I am giving one data, the data needs to be processed. So process means when my sensor from my fridge, it's going to send to mobile. So some process needs to be done there. So those kind of process will be going to execute in stage 3. So we can tell identifying the egg and identifying the rice. So those kind of identification we can able to make with the stage 3. This is mostly the data analytical stages. Stage 4 is a complete physical data center or cloud, which is going to manage all your data. So in that video, so some mechanics come by 11:30 means I need to save my data. So in my home by 11:30, that mechanical came last week. So I want to store all the data securely. So for the storing purpose, we need the stage 4. So this 4 stages is actually very, very important in your IoT. Without this 4 stage, you can't able to implement any IoT device. So when it comes to in-depth about your AI and IoT, data science and IoT are, see when the data are more, we need to process the data. So definitely we need some data analyst there. So when I want to make my machine to understand the fuel level or the eggs or the rice, or I want to understand my machines to switch on, switch off, and I want to understand my track the system. So tracking means if the son and daughter went by school by 9:05 means the mom and dad is receiving your son and dad is actually reached their school. So I need to track the peoples. So for the tracking, so for all this perspective we need artificial intelligence and voice recognition. That is the concept which is known as NLP, natural language processing. So I am telling even your Google Analytics, sorry, your Google Assistants and your iPhone Siri, Amazon Alexa, this all actually work based on NLP only. NLP means natural language processing. What is natural language? That's nothing but human language is your natural language. Okay, so when I am talking something, my machine needs to understand my voice, and the machine needs to understand human language. That's what your natural language processing is. So this natural language processing is the thing where we are actually processing with the help of artificial intelligence. So this is the very first concept you guys need to understand. Okay, so hope now you guys cleared about this 4 stage. So your other doubt is, if two devices connected without emitting any data, can we call that is an IoT? See, IoT means connecting and communicating with each other, and there is no need of connecting two devices which is not going to emit any data. Correct. So when you are just connecting two devices means definitely it needs to send some data. So if it's not sending a data means there is no need of connecting two devices. So for example, you are connecting your mobile with your Bluetooth headset. If your mobile is not giving any output, so what's the purpose of connecting your mobile with your Bluetooth? It's not needed, right? We can't tell that as we can tell that as IoT. The reason being how I am telling is we can able to tell as an IoT is, see, connecting devices is IoT. It will definitely emit the data. Without emitting any data, we are not going to connect any devices. So that's the concept. Yes, obviously when the devices are connected with each other, we will definitely get some sort of communications. That's actually there. So now that's actually a very good question. You will definitely get some shortage in that communication. So for example, we are connecting your Bluetooth with your mobile. So when we are driving, we used to get some signal loss, correct? So this are the things that's actually there. Okay. So those kind of disadvantages also there. Now we are going to discuss about the disadvantages only. Okay. So you guys having any doubt in the stage 4 still, you can feel free to ask me. Otherwise, I will start with the disadvantages. What are the disadvantages there and how to overcome the disadvantages? I will start with that. Any questions, guys? Okay. Where is the cloud stored? See, okay, I will give a one small example for this. You are using Facebook. So all the Facebook data are actually cloud data. See, if you are logging into your Facebook, any device, any place in this world, you will definitely, you can able to retrieve all the data. That's actually cloud. It's a kind of virtual things. It's not actually storing. It's a kind of your Gmail, your Google Photos, and your Facebook Messenger. This all actually cloud data only. So it's a kind of virtual. We have some physical centers. Each and every companies, they used to have their own cloud centers, so we are not actually accessible to that. So for example, they like SQL or database centers, we do have a cloud centers as well, but not that much big, because reducing these spaces, it's a main concept in cloud. So simple example for your cloud is your Gmail data. So you can able to log into your Gmail anywhere from this world, and if you can able to log in from any device. So once you give your account ID and your password, you can able to get all the data. But if you have some data in your system, you can't able to access in other system, correct? So that is all local storage. So this cloud storage are your Facebook, your Gmail, all those things are your cloud storage kind of things only. It's a virtual things. We can't able to see like the normal physical devices. So that's the concept there. Okay. So any other questions? Okay. So I think you guys are good to go with this architect. So let me start with the next thing. So the next thing is your disadvantages. And what kind of fields that's all there to overcome these disadvantages. Okay, coming back to our video. So there is something missing. So your car fuel is less than this level. So I need to start little earlier. So I need to start within 2 minutes. Then only I can able to reach my office on time. Okay. So this everything I am listening only to my machine. I'm not listening to my mind. I'm not listening to myself. We are actually listening to the machine, and each and everything is connected to some data center. That's nothing but the cloud. So all our data is actually shared with someone else. So or with some companies, it's actually shared with someone else. So definitely we don't have any privacy there. So this privacy issue is the very big disadvantages why some peoples are not accepting IoT. So when you are going ahead with IoT, it seems to be very cool and good, but the thing here is we are losing the privacy. So losing the privacy will leads to many kind of problems in future. So for that perspective, we have a network security kind of things. Security, IoT and security. This is that very, very important domain in IoT. So what it will do is it is going to improve or it's going to increase the privacy and security for each and every person. So that's known as network security. And apart from, we need a networking is a very, very important thing in IoT. The reason being is, see, when one thing is connected with another, the other thing is connected with another, so each and everything can able to connect and communicate with each and everything. So there is some kind of data exchange is happening. So this data exchanging is what your networking is. So if I need some kind of data exchange between the devices, we definitely need one complete network structure. So the complete network structure is what our IoT networking is. So the normally you may aware of the switches, routers, the CCNA, those kind of networking. So connecting networking and IoT together, it's a kind of IoT networking. Okay, that's the next thing. So the next stuff in IoT is IoT protocol development. So protocols are very, very important because by using protocols only, I am just going to carry my informations between each other devices. So we have a very famous protocol in IoT, that's nothing but MQTT or mosquito protocols is very, very important in this field as of now. So still we are working on more protocols. So those kind of protocol development is another field in IoT. So apart from IoT product development. So IoT product development means what we are actually doing here is there is one circuit. I will write the code for the circuit and I will implement the camera, AI or the analytical, and then I will implement the communicating devices, and then I will implement other things. So when I am implementing each and everything towards this, I can able to make one complete working model. So the making the complete working model is your IoT development. But in the back end, we need the protocols, and then we need the security, and then we need the network. So connecting everything with each and everything, we need one complete network. So the network protocol and the network testing and the network security and then this IoT development. So this four field is very, very important field in your IoT. So in future, if you guys wants to, okay, if you want to become IoT expertise, you can choose any one thing from this four field because we can able to go with any one field only. So if you want to go for an protocol development, we definitely need 100% programming language. The protocol development needs 100% programming language. So mostly you guys needs to focus on a little bit of networking, little bit, very, very little bit, that is more than enough. And then scripting languages. Nowadays we are using Python only. So Python is the scripting language which is needed for protocol development. Previously some other languages like TCL TK also used, but nowadays Python only the most used language. So Python using you can able to develop any protocols. When you are going for a IoT networks or IoT security, this two thing is 100% tool used stuff. Peoples who don't have an interest in programming, so you guys can choose IoT network or IoT security. But for IoT security, hacking is very, very important. Okay, the reason is if I want to hack, so for example, I will just give one small example. So if I am implementing my home automation in my home and my neighbor also having the same home automation device implemented in their home, now I want to break their voice and I want to do something else. Okay, so what I will try to do is I will decrypt the algorithm. So I will try to log into their house. So I will go inside and I can do something whatever I want to be, but I'm not supposed to decrypt that. So for those kind of security things, we need that network security with hacking. So for the security purpose, you need 30 percentage of coding, and then 30 percentage of the circuit knowledges, and then 40 percentage mostly people will use tools. And then when it comes to networking, IoT networking, you guys must be aware of electronic devices, that is mandatory. And then networking concept, mostly industry will prefer the peoples who's having at least some certification in networking. Okay, so these are the things that you guys needs to be focused when you are very much interested in coding part and you want to upgrade your skills. So the 100% coding, the 100% circuit as well, implementing these two things, if if you guys are really interested in that domain means, I will recommend you guys needs to go ahead with IoT development. So the person who's entering into IoT development must be having an aware of, it's a kind of full stack people. So the person needs to be aware of cloud, the person needs to be aware of networking, the person needs to be aware of circuits, the person needs to be aware of programming as well. So because the person is actually going to develop the full structure. So if I am a network security expert means, I am going to make an algorithm where I can able to implement only the security steps. If I am a network engineer means, I am just going to work on only this Wi-Fi routing, those kind of things. But the person who's developing the complete IoT, the person needs to be a full stack people, so who can able to handle each and everything. So all fields are good. So if you guys wants to become some IoT developer means, you need to choose from this four fields. So like this all your job based advice. So the question is cloud data. See, cloud data means simply telling you are just going to store your um, details, and you are just going to manage, and you are just going to analyze, and you are just going to maintain each and everything. So simply telling, when we are going ahead with your cloud, your Google Photos. So you are capturing one image in your mobile. So automatically from your gallery, Google Photos retrieving that. So in case if you're deleting the photos from your mobile itself, you can able to get the data later in Google Photos, correct? So when you are getting back, even you can able to retrieve after you are deleting from your mobile. The reason being is that photo is actually stored in cloud. So simply telling, when you can able to access the data only in your local system, that's a local storage devices. When you can able to access the data from anywhere of the world and anywhere, any devices from this world, that's all known as your cloud. So for example, your Google Photos and your Gmail and your Facebook, these are the cloud data. So we don't have a physical structure for cloud. Mostly we do have a physical structure, but not that much physical structure. So to reduce the physical structures only, we are going ahead with the cloud. So cloud is a virtual part which is going to store and manage and to give more secure to our data. So that's what your cloud is. Okay. So hope you guys are clear about these things. If you have any questions, kindly ask me. Okay, I will just move forward. So any questions, kindly chat here. So I will explain in the mid. So as we discussed about this architect and the jobs and then fields in your IoT, we needs to discuss about the boards, the embedded boards. Okay. So a few years back, by 2002, 2004, in this kind of years, we do have only embedded system. So there is a two kind of things in our embedded. One is microprocessor and another one is microcontroller. Hope as you guys are from your electronics background, you may aware of what is processor and what is controller. So when it comes to controller, everything will be inbuilt. Your input, output, everything, all the controllers will be there. Processor means you are just going to hold only this exact chip which is going to process the data. So when you are going for your microcontroller, we have a 8051, ADMEL, ADMEGA, and then ARM. This all some kind of microcontrollers we do have. So this is the basic structure of your microcontroller. So you are going to give some input. The input may be a sensor, or it may be a switch, or it may be a keypad, or it may be a timer. So this microcontroller will process the data and it will give the output. So the output may be it may be any kind of notification. Correct. So it may be your LED or buzzer, or it may be actuators or switches, whatever itself. And we do have a display units as well, the 7 segment display, those kind of display units as well there. And then we used to make the connection for your IoT with RFID and GSM as well. So this RFID, GSM, Bluetooth, this all used to map your input output or to send some information. For that mapping purpose only, we are going ahead with this RFID and GSM. So when we are actually making this complete structure is what your microcontroller is. So now this microcontroller are actually upgraded to some modern boards. Okay, so previously when we do have a microcontroller, we used to develop everything by using C languages only. Your C++, that is actually upgraded to embedded C. So by using embedded C, we used to develop the program for this microcontroller and microprocessor devices. For each and every separate boards, we do have a separate syntax. Concepts are same only, but some of the syntax data types will be used to change. So for example, I can't able to use the same program for PIC and ATMEL, for PIC and ARM. So for ARM, I need to develop the different code in a different IDE. For PIC, I need to develop a different code in a different IDE. So this all some kind of advantage and disadvantages. Sometimes ARM is actually very good processor comparatively to others, but it's quite costlier. So each and every microcontroller used to have its advantage and disadvantages. So industry usage, mostly people will prefer PIC for a middle scale industry, and ADMEGA for small scale industries, and ARM for the large appliance. So the Intel and those kind of companies, they will mostly prefer ARM processor only. So this all that in embedded field. In embedded field, we used to have all those things. So slowly the embedded field is upgraded to your IoT. One of the main reason VLSA also, because embedded VLSA, it's all like a twin brothers. The reason is without VLSA, embedded domain can't able to upgrade. Without embedded, VLSA can't able to upgrade, because in the VLSA, we are just going to increase the transistor rates in each and every ICs. So that's the main concept of VLSA. So they are increasing the transistor amount in the processors. We are now actually upgrading to the modern boards. So when you are just going ahead with IoT, we are not using an IoT in the normal embedded systems. We are actually using with modern boards only. So this are some embedded board systems. So it's a basic view of your embedded. So this is the processor. So here you have an input, and here we have a connection for output, and some of the switches also there, and then your processor and your chip, diode, everything is actually inbuilt. So this is the basic view of your embedded board. So by using these ports, we can able to connect with keypad or timer, whatever we want to connect, we can able to connect. And based on this VCC, we can able to connect with your power supply, and ground, we can able to connect with this boards. But when it comes to modern boards, this are some modern boards available like Arduino, Raspberry Pi, Banana Pi, Orange, Onion, Intel boards, MSP launchpads. This all some boards that's actually available now. So the reason we are going ahead with modern boards is, see, in these boards, if I want to convert my analog to digital, digital to analog, I need to use one more component, that's nothing but DAS, and I need to connect with the sum of this port, and I need to process the things. So conversion, the data conversion needs a one more step here. But in modern boards, that's all no needed. It will automatically convert. So it's used to convert, and it's used to process the things. So those kind of processing will be reduced in modern boards. That's a one advantage. And when I want to connect a camera or video processing, something with this embedded ports, again, I need to process a lot of things. But when it comes to modern boards, even your Raspberry Pi will come with your camera adapter itself. So there is no need of too much of processing here. So that's all what that simple difference between your embedded board and modern boards. Modern boards, that is nothing but embedded board only, which is the upgraded version. We can tell something like that. So mostly, I think you guys may heard about Arduino Raspberry Pi, but this Onion Pi is very useful for the peoples who are going to work in network field, because this Onion Pi is mostly used as a VPN, virtual private network. So for those kind of purpose, Onion Pi is very useful. Apart from, you can go ahead with Raspberry Pi itself, that's more than enough. Intel boards and MSP Launchpad, we are not preferring here for the class purpose. The reason is it's quite costlier comparatively to Raspberry Pi. So these boards are very costlier. But if you know how to handle Raspberry Pi, handling Intel boards and MSP Launchpad is somewhat easy for us. So when you are going for a programming languages, you can able to develop by using a JavaScript, by using Python, by using a Perl, by using your C programming, C++ as well. We can able to develop your IoT products even with the MATLAB. Okay. So industry, we are preferring Python. The first thing is it's open source. The second thing is it's easy to learn. And the third thing is Python is having already defined libraries to handle Raspberry Pi, Arduino, Banana, Orange, Onion, Intel, MSP. So you can easily handle all the boards with only one programming language, which is having its library already there. So that's the reason we are choosing Python instead of other programming language. So the other best way is a C program, but C program is only applicable with Arduino, because Arduino C is the only one thing which we can able to applicable. When it comes to your Raspberry Pi, is actually pre-built and it will comes with your Python only. So for that perspective, we won't prefer other programming language for Raspberry Pi. We will definitely go ahead with Python only. In case if the people wants to go ahead with other programming language, some people will refer JavaScript. But the problem there in JavaScript is we don't have a pre-built library for to handle the embedded devices in JavaScript. First, we need to develop the libraries, then we need to process, which will be take more time. So for that perspective, we are not going to even prefer JavaScript. MATLAB is another good one, but the problem for MATLAB is costlier. It's not an open source like Python. And comparatively, MATLAB is not that much easy to learn the things. So for that perspective, even in industry, we are going ahead with Python. For all the boards, nowadays Python is applicable. Okay. Is it not audible? Yeah. So choosing a programming language is another important thing for us. So we are choosing Python instead of others. The reason is easy to learn. And one more thing is Python security wise, it's very good. And it's an open source. Okay. Let's we start with the next thing. Before that, I will give 2-3 minutes time gap, guys. So I think you guys needs to register with your attendance now. So I'll give 2 minutes time. Kindly punch your attendance. So we'll go ahead with the next one. Okay, guys, I hope you guys are done with these things. Let's we start with the next thing. So this advantages that I explained, so we can able to make a communication, this DAS, everything inbuilt at, and the most important thing is only we need to pay for boards, the embedded boards, but not for the IDEs or programs. Okay, so when you are just going ahead with your modern boards, see, we have a digital pins, we have analog pins, and we do have a power pins, and we have a power jacket, and we do have a voltage regulators, and we have jumpers, USB, and then USB chip, and then you having a transistor receiver. So this is your transistor, and this is your receiver, and this is your reset button, and this is a power button. So mostly everything is inbuilt here. Okay, but when you are going for this normal embedded board, see, we have only microcontroller, we have only microprocessor, and then we do have some of the connection. So we don't have even analog digital converters. So we can able to give only analog input. So again, to get this as a digital, again I need to use a DAS. But in this modern boards, I do have my analog input and I do have my digital output. Even I can able to get my PWM as well. So one of the simple example for my PWM signals are my lifts. So lifts, the SCADA, it's all actually works based on my PWM signals. So apart from, we do have a transmitter and receiver here. So if I want to connect with the GSM, or if I want to connect with my Bluetooth, I can able to use this transmitter receiver here. So mostly the input pins we used to give here, and that output pins which you are going to connect with actuators or the boards, we can able to make it in a digital outputs. So the next thing is, when we are going ahead with your microcontroller for Arduino, it's actually coming ahead with Admega. So that's nothing but your Admel company. So this is your processor which is going to process the things. So by using a USB jack, you can able to connect with your system easily. So you can able to develop any programming language, and you can able to connect with these things. And then your power jacket, you can able to connect with the external power supply, else we can directly connect your battery to this 5 volt, 3 volt like this. And this reset button, which will help us to reset the devices, so we can simply go ahead with the things. So this is a simple example between your boards. So when you are going for Arduino, your Arduino it's having your ADC, that's nothing but analog to digital converter. So you can even do one more thing, that's nothing but you can able to convert your USB to PWM ports as well. So when you are converting this PWM ports, you can able to easily handle the relay, sensor, LCD, everything. And we do have a 5 volt or 3 volt powers, both we do have. We can't able to give more than 5 volt. Even 5 volt is not advisable. It's better to go ahead with 3.3 like that itself, because this Atmega processor will always burn when you are just giving over power. So for that perspective, it's a disadvantage of Arduino. When even if I am giving a 9 volt adapter also, sometimes it's used to be burned. So we mostly prefer only 3.3, 3.5 volts for this Arduino. So we can able to connect a multiple devices as an input and output. No need of soldering and all those things. But when we are going for industry purpose, definitely we need to solder and do those things. But normally for that execution level, no need of that complex structure. We can simply execute the things. And your serial connections you can able to make from 0 to 16 actually. So by using this 16 pins, you can able to get even multiple outputs. For single input, we can able to get the multiple outputs. Multiple outputs means your LED, and I can able to get a buzzer, so I can able to make a multiple outputs like this. So that's what your multiple output things is. So when you are choosing Arduino, in Arduino itself, we have a multiple boards like a Nano, UNO, and then Duke, LilyPad. So we do have a multiple versions for Arduino itself. Industry purpose, Arduino, it's not advisable. In case for the budget based products, we may prefer Arduino Mega, but mostly we won't prefer Arduino for interview purpose. The reason is it won't handle, or it won't tolerate the temperatures. Okay, so mostly when we are implementing this kind of boards in power plants or chemical industry, mostly for chemical industry, we should not prefer Arduino boards. The reason is that temperature is already high. So if you are going and implementing Arduino there, it will definitely going to be lose its tolerance. So for that perspective, we won't prefer this Arduino boards for this chemical based industries. We will always prefer ARM processor or this Intel boards for those kind of perspective with coolers. Without coolers, we can't able to implement the things. And when it comes to Raspberry Pi, even your onion, banana, all this are same thing. See, it's a single motherboard. You can tell this is a motherboard. See, it's a Broadcom processor with whatever you are having. This is that main brain. So this is the main brain of your Raspberry Pi. Okay. So this all your input output pins. Okay. By using these things, even I can able to connect with my cameras. And here we do have a HDMI, and here we have a USB, and here we have a Ethernet connection, and this is a power jacket, and here I can able to, this is again the power jacket only, 5-volt power jacket. So even the normal our mobile charger itself more than enough to connect with this. See, in Raspberry Pi, we can able to get the output only via monitors. So like your system monitor or your TV, by using those kind of monitors only, we can able to develop the things. Because the Raspberry Pi is the kind of thing which is going to give a OS, okay, operating system. It's a operating system. It is a kind of mini computer only, okay. So Raspberry Pi own OS is Raspbian. Okay, Raspbian is that OS which will preferable for Raspberry Pi, but we can able to load any kind of Linux of Linux OS or Unix, Windows, any kind of OS you can able to load with Raspberry Pi. Some peoples, they will prefer Windows IoT OS, which is to be implemented in Raspberry Pi. Okay, that's a very another thing. So when you are going for Raspberry Pi, it will support any kind of software. So it supports Python, Java, Android, C++, any kind of software can be able to use in Raspberry Pi. The another advantage of Raspberry Pi is you can able to handle API. So this API discussion will do have in our last day of the session. When you are going for your IoT, API is another important thing which you are going to handle the things. Okay. So to handle the IoT, Raspberry Pi is, to handle the API in IoT, Raspberry Pi is more efficient and economic to go ahead. So the another thing is your Raspberry Pi is mainly used in your automation and robotics, those kind of fields. We can able to use your Raspberry Pi. And apart from for the network security, hackers, those kind of peoples, they can easily go ahead with Raspberry Pi. So for the security purpose and for the hacking purpose, Raspberry Pi is very good. And for IoT development, comparatively to Arduino, Raspberry Pi is much good for to connect with the sensors and to handle the things in a much better way. Raspberry Pi is, they used to tell that is a costlier, but it's exactly not costlier when you are comparing with the Intel boards and Tesla boards. It's cost 3,000 or 5,000 around when you are just going ahead with your Raspberry Pi. we will be getting an inbuilt Wi-Fi, Bluetooth connection, everything. But Arduino nowadays it comes with that inbuilt Wi-Fi and Bluetooth. But if you are going for inbuilt Wi-Fi, Bluetooth with Arduino, then again it's costlier only. It's almost equal to Raspberry Pi only. So we don't have any cost difference between the things, and it's actually good to go with Raspberry Pi for IoT development. But before you are starting with Raspberry Pi, if you know Arduino, that is actually cool enough. The reason is, if we first develop some small projects in Arduino, that will help us to develop the very big complicated projects in Raspberry Pi, because Arduino is very easier to handle, but Raspberry Pi is little complex to handle. So if we first handle this Arduino, ESP8266, those kind of boards, then if we are handling this Raspberry Pi, that will make us more easier to process. So that's the thing here we are doing. Okay. Okay. So I think we are good with this Raspberry Pi and Arduino explanation. So apart from, we have one more board that is nothing but ESP8266. That's actually a part of Arduino only. That's actually comes with inbuilt Wi-Fi. Okay, so that's a one advantage there. Comparatively to Arduino, that's actually good to tolerate with temperatures. Then Launchpad. So Launchpad is actually a ARM-based CPUs. So this actually good to go for the cloud connecting devices, because this is the very first IoT device which comes with cloud connecting. Okay, so this is the very first thing. Apart from it having the same features like Raspberry Pi, this PWM support and EAC, all those things are actually available here as well. It's also CPU and its speed is little higher comparatively to Raspberry Pi. So apart from, you can able to handle JavaScript, Python, MATLAB, any programming language in Launchpad as well. So if you know Raspberry Pi, you can easily handle these things. We can't able to afford this cost, so for that perspective only, when it comes to this training kind of things, mostly people will prefer Raspberry Pi and Arduino, because if you know these things, that things also easier. But when it comes to interview perspective, we need to invest more money, because it's all that very high level development. So peoples in industry will prefer Launchpad and Intel only. But no need, if you know Raspberry Pi, you can easily adapt. Some companies, they are using Raspberry Pi. The peoples who are into network, IoT network security, the IoT and network peoples, they will mostly prefer Raspberry Pi only for their implementation purpose. So these are the basic introduction. Then when it comes to your IoT devices and technologies, see, when you are just starting with your IoT, we need to go for this hardware, and then you need to go for this platform and services as well. So when you are going for this platform and services, it will come even with your protocols, those kind of things. So these are some kind of protocols that we are just going to handle with you. It will help us you to handle your IoT. When it comes to your hardware, we have IoT devices, accessories, and smart devices. So the smart devices, that's nothing but GPS, RFID, Bluetooth, those kind of things. When it comes to your accessories, that's all nothing but relays, displays, switches, actuators, sensors. So we do have a lot of sensors. Depends on our what to say. Depends on our requirement. We used to get these sensors. Okay. So when it comes to actuators, that's all your motors. So for the peoples who are going ahead with your robotic field, mostly prefers stepper motor, because robot will go with step by step, and servo motor as well. So then displays, of course, this LED, LCD, 7 segment display, this lights. So that's all your displays and relays. So this all some kind of accessories we may use. And when it comes to simply IoT devices, wearable and embedded system based. Embedded system based are nothing but your Arduino, Intel boards, Raspberry, and something even your micro frameworks, your BeagleBone, and this kind of things also there in your embedded system. Then when it comes to wearable, watches, mostly they used to tell watches, some kind of coolers, the goggles. So this all some kind of wearable. So when you are going for an IoT, the person needs to handle all this complete network, the IoT product development peoples. So this is your IoT deals. And then this all some kind of real-time application which is actually implemented, already implemented. Okay. So your alarm will on when your coffee machine is done. Okay, this is actually done, one of that IoT. And then this kind of one baby pajamas. Okay, so which is actually developed by this Pico monitoring design. So what it will do is when the infant will fall down or any kind of symptoms or any heart rate which is crossing the limit, if it happens something like that, the people will get, the parents will get text messages, phone calls, something they will get. Okay, this application is 100% developed by REST API. So the REST API, using the REST API, they developed these applications. So when you are going ahead with your IoT, we can able to implement your IoT in a smart home, IIoT, agriculture, supermarket, and a smart grid. Okay, smart home. The example, that video which we store, which we seen now. IIoT. That's nothing but industry Internet of Things. Okay, so I am going to implement IoT in my industry. So, for example, power plants. So, when one plant is getting the more gas leakage, the particular person will get the alert. So, those kind of things. So, when I want to implement the IoT in case in my IT sector, so for example, there is one data center or cloud. So if some wire gets connect, some wire get disconnected. Okay, uh, the technician will need at least 2 hours time to identify which wires get disconnected. Okay, so if it happens in midnight or if it happens in the early morning, so if one data center is disconnected with one wire means half of the peoples they can't able to access their application. Okay, this kind of problems was happened 10 12 years back actually, but now due to this help of automation and all those things, we are not dealing with those kind of problems nowadays. Okay, so when we are going ahead with your IoT applications, this IIoT, in case where the wire is disconnected, the technician will get the alert. Okay, and the technician even they can able to switch the data center or they can able to switch the database from one to another without visiting the data center. Okay, so if it happens in early morning, by using that mobile application itself, they can able to do all those things. That's what your that's kind of things will happens in IIoT. Then when it comes to the supermarket and smart grid, this I will give one small example video now. And when it comes to agriculture, automatic water and then sending a notification about this water, soil, policing, those kind of things we can able to implement in your agriculture. So when it comes to supermarket, so one person instead of waiting and instead of if we are going for a DMart and all, we used to wait in a very long queue, right? So instead of waiting in the queue, if I have a QR code in my basket itself, I can able to scan my product and I can able to put it in my basket. And if I don't want that, I can able to get that back and I can again remove from the list by myself itself, and then I can put it back. And instead of waiting in the queue, once I reach to my door, if I can able to swipe my card and I can simply go ahead. So that's these are the kind of things that will be happens in supermarket. For the smart grid, I will give one example video. Just 1 minute. So if you guys having any questions, you can simply ask me now. So this is an example for smart city. So if IoT is applicable to your city, your own city, how this IoT is going to work around us. So that's a small video, example video for you guys. So this all that advantages. So it economic and is user friendly, and even it will help you with all that each and everyday activities in your road, and it will help us to improve this economic value of cities as well. So see, when you are just going ahead with the smart city, if the person needs the parking space or the street lights connectivity, and if any even though if there is some accident also, we can able the police and the ambulance can able to get that alert. So this kind of things, when we are just implementing, that's all your smart cities. Okay, so your IoT is actually applicable with almost in all the domains. Depends on the domain, using boards, network security, and then a programming language, and then sensors will varies. But the concept, architect, flow is actually common for all or everyone. Okay. So the question is, WOT is different from IoT. Okay, WOT means Web of Things. IoT means Internet of Things. There is no difference in this. Applying a web protocols to the Internet of Things, that's what your WOT is. So for example, now if I am implementing some IoT in my industry, okay, when it comes to industry, they will mostly prefer intranet. Okay, so that is nothing but in based on my network connectivity only, I can able to access the things. Even you can't able to access based on your mobile network as well. Okay, so some companies, they will do the complete connections and the complete controllers in the web only. So I want to switch on the particular tank in my chemical plant. So I will create one web application, and in application I will put switch on off for the tank 25. Okay. So now I am using a web application for to control my tank. So I am implementing a web protocol in my Internet of Things, and I'm controlling my devices. That's what my WOT is. Clear? So this is what your WOT is. So you guys can ask your questions. So I just give you the basic introduction about IoT, how IoT is applicable, and how IoT is used in your job. And when you are going for IoT with analysis, okay, Hadoop, big data, this kind of things, it's actually implementing along with IoT. Okay. So when you are going for your some cities, what they are actually doing is all the data they are actually gathering and monitoring in the computer. Okay, without implementing any humans. Sorry, without involving any humans, they implemented these things. So if I am parking my vehicle in no parking, if my city is a smart city, the police will get the alert. Automatically, I will get the message of fine. So, sometimes automatically detect from bank account as well. So, this kind of analyzing. So, the complete analyzing also we can able to make it. So, there is no need of human involvement in this. So the peoples in South Korea are actually using this kind of the complete processing the things. So it will help you guys to reduce the pollution, and it will help you to reduce the noise, and then it will help to improve the water and air quality and all those things. So big data, Hadoop, all those things are actually implemented here. When it comes to your IoT with cloud, we have a three different things: platform as a service, security as a service, infrastructure as a service. IoT cloud architect is a one kind of role, so that people needs to go ahead with all those things. As we are developers, IoT developers, we have an idea in platform as a service only, because I need to connect my IoT device in the cloud platform. So for that perspective, platform as a service is more than enough. That other two domains will be handled by the cloud peoples. So us again, we need to be cleared about each and everything. So the next thing is WOT only. So the WOT, that is nothing but web of things, which is going to improve the connections of your web application and your Internet of Things services. So it will offers you the API protocols and any programming language, even your PHP. Also, you can be able to use as a web of things. See, your question is like traffic. Yes, of course, it's useful in traffic. If accident happens both the sides of the road, then again, based on first in first serve. Okay, always all the electronics or programming language will works like first in first out, and Python is an interpreter. So if you are developing anything based on Python, so definitely the first input. First we are going ahead with that first message what it's received, it will send that notification to the nearby thing, then it will go to the next thing. So step by step we can able to achieve the things. See, security concerns, again, privacy matters, and apart from security wise, the peoples are kind of still we are in this improvement phase only. Still we didn't achieve the 100% security for this complete IoT. That's the reason still IoT is not 100% implemented. So IoT security is the kind of things we need to increase more. The reason is the privacy is stolen. Apart from somewhat, it is actually 50-50 it's achieved security wise. Apart from, we don't have a privacy based on the security, so that's the one and only disadvantage as of now security wise. Apart from everything is actually algorithm based, the same like your mobile is locked with your fingerprint. So if even I'm stealing your mobile, I can able to decrypt and I can able to get all the details from your phone pay, Google Pay as well. But still you can able to achieve the things, the same level of security only as of now available in IoT. But in future it will definitely improve that concern. So for that perspective only, nowadays network, IoT network security field are in most wanted field nowadays. So other questions, guys? What are the main parts of IoT systems? See, we don't have main parts kind of things. We have only architects. So that stages which I explained, no. So I'm not getting like main parts means you are asking based on electronic devices, or you are meaning only this architects, because parts are input output one processor. That processor is what our modern boards is. Input is a kind of sensor, so output maybe actuators or motors, like whatever it's. So that's the thing, only the architect. Yeah, electronic devices, as I explained here, no, like the devices which is all for this, everything, that complete architect which I shown here, it's a complete your parts. So depends on your requirement, you need to choose which kind of boards or which kind of input output we need to select. Okay. So any other questions, guys? See, different thing embedded device and Arduino. See, one of the embedded board is Arduino. Okay. So the normal embedded devices which don't have your DAC, like analog to digital converter and the PWM output, and then this kind of Ethernet connection. So this kind of things are not actually available in the previous embedded boards. Okay. But Arduino, it comes with the DAC and it's having its input output pins. So there is no need of one more connection of one more devices like analog to digital converter. Arduino comes with inbuilt the things. That's actually difference. Upgraded version of your embedded devices is all your modern boards. That's what the difference is. See, in agriculture, IoT is something. See, we testing the soil. Okay, Reliance is actually doing the things, testing the soil, and for the soil, based on the soil, how these things, what kind of things I can able to put it there. So for those kind of research, and then automatic water irrigation system, and then securing from the overheat kind of things. So if it's like, if it's more temperature means, it automatically puts some kind of the things, some kind of filters you can able to put it. So those kind of things actually they are implementing in agriculture. No, actually, Arduino can take input itself. No, Arduino, see, it will take an input and it will convert your analog input to digital input automatically. That's the only one thing Arduino is actually. The modern board is different from your embedded devices. Okay. Okay, regarding sharing the personal details and PPTs, the coordinators will get back to you guys. I think the recording session and the PPTs, I will ask them to go ahead with the things. Okay. Okay, so I think Rahul, you are clear with the doubt. It's a processing itself, not. It's only converting analog to digital. See, I told now, Arduino, we need to develop the code by using an Arduino C or Python. Okay, so you can use Arduino C or Python to develop the code for Arduino. Okay, so any other questions, guys? Super. I really appreciate you guys that you guys come up with very good questions. So tomorrow sessions also I will yeah, I will just ask the coordinators to come ahead with that PPT sharing and all those things. I will ask them to do something for that, guys. Okay, so I think today we are good to wind up. If you guys having any further doubts, we'll continue in our tomorrow session. Tomorrow session, we will go ahead with Arduino, Python, those kind of things. Tomorrow we're going to discuss. Okay. So thank you guys. Thank you for the feedback. Yeah. I'm not sure about the hands-on experience within this 5 days, but I can able to give some kind of hands-on in a programming. Okay. Yeah, guys, if you guys installed Arduino C and Python in your system, that could be appreciable. So I will give some small task. So you guys can try in a session. So we will discuss your doubts. Programming wise, I can give you the hands-on experience. That's for sure. But that connection and all those things, probably in future, if you're we need to set up the things. If you guys having Arduino sensor, everything we can able to do. As of now, I will be just going to explain with some small circuits kind of things. I will try to explain. Okay, guys. Thank you so much. We'll meet you tomorrow, guys. Good night all. Take care.